All right, so today I want us to look at the basic block functions. In the other video, I introduced a couple of them, but today we're going to look at all of it, and so that you can have a broader understanding of what the basic block functions look like. So I hope that everybody has seen linear functions before. All right, these are our lines that you learn, slopes and parallel lines and perpendicular lines and all that fun stuff. But I have this graph over here, which is a horizontal line passing through the y value, y equal to c. All right, so that's the equation, y equal to c. And you can see that for every x, it's got a corresponding y value. So the domain is all reals, but the range is only y is equal to what? Y is equal to c. It only has y, so not equals, but y belongs to just one element, which is what? Which is 3, which is c. No, I thought 3, which is c. All right. And then you know how to sketch a line. A line can either rise from left to right or fall from left to right. In this case, it's rising from left to right. And the way we sketch is we locate B, this is B, and then you do rise over run to find the other point, and then you connect the two lines together. So again, if I look at their domain, this function is going forever. The domain of a line is all reals, and then the domain, the range of a line is also what? All reals. Hopefully these two, you've seen them and you've worked on them in your Algebra 1 experience, okay? Now the rest, we're going to see. So these we are calling linear functions. As long as they are lines, we're going to call them linear functions. Now let's look at the next set. So the next set, I want you to be open-minded and be ready for this. We're looking at what we call power functions. So power functions are functions that have x to the n. All right, so we're going to look at even powers. All right, so even powers are 2, 4, 6, 8, they're even. So if you look at the graph that I have on Desmos over here, I plotted x squared, x to the 4th, x to the 6th. I encourage you to take your calculator and also plot them, plot these three, and see what's happening. If you look at x squared, that's the red curve, and you compare with the blue and then the green curve, you can see that the higher the power, the even power is, you can see that the base is flattened, but the curve is the same nature. All right, it looks like a parabola, but then the base starts to flatten out at the origin, the higher the even powers are. The domain and range are going to remain the same, doesn't change. The domain is all reals, and then the range is also what? Is also all reals. From what? From 0 to infinity. But look at how the curve is changing, all right? So if I gave you x to the 10, you don't have to panic. You still know the nature of this graph. The graph is going to look like a parabola, but it's got a really flattened base. It's really flat. It's x to the 10. So let me show that it's really x to the 10. So it looks like it's flattening out. All right. So that's how we want to look at this if you have an even power when you're dealing with power functions. Now let's look at the odd functions. So these are odd powers. So odd powers are 3. Well, you start off with 1, but if it's 1, it's linear, right? If it's 1, it's a linear function, but we're not looking at that. 1, 3, 5, 7. So if I look at x cubed, x to the 5, x to the 7, we already saw x cubed in the other video. So if you look at it from odd powers, you can see that the graph is very similar to the red line. The blue and the green looks very similar, but again, see what's happening to the base over there. So it's also flattening out when you are at the base over here. So the higher the odd powers, the more flattened it is around the 0, 0 portion. So you recognize these and you're able to kind of use it to help you scale certain functions that doesn't come readily to you. But if it's odd powers, this is how it looks like. It's increasing from left to right in all cases, but it's flattening out at the what? At the 0 point. All right, now let's look at root functions. So root functions, again, is something that has a radical in it. Again, let's look at even powers. So that's 2, 4, 6, 8. Now, a radical with no index is a square root, right? So that's a square root, that's the fourth root, that's the sixth root. And if you look at the graph, it looks like the red starts, the red starts this way, goes there, and then blue and green, they're straightening out on the y-axis. They straightening out over there. So again, you know the nature of the graph. The higher the power is, the more flattened it looks on the y-axis. Okay? And then when you look at odd powers, I'm looking at the third root, the fifth root, and the seventh root. This is how the graph looks like. It looks like it's like an S. And all right, it's kind of stretched out S. And then you can see that it's also flattening out at the what? At the y-axis. So the blue one is the first one, and then the higher the power is, the more stretched it looks like on the what? On the y-axis. But this is the nature of the graph, all right? And then let's look at reciprocal functions. So reciprocal functions looks like 1 over x to the n. So I'm looking again at even powers. If I look at even powers, I have 1 over x squared, 1 over x to the fourth, 1 over x to the sixth. The graph looks like that. It's got what we call a vertical asymptote, and it's also got a horizontal asymptote. It's hard to show that on the graph, but I tried to kind of show that anyway. So you can clearly see that the graph looks like this, and it looks like that. All right. And the higher the power is, the further away you are from the y-axis. All right. And the closer you are to the, where is it? And the closer you are to the what? To the x-axis too. Okay. So this graph is going to behave the same way all the time. All right. But what's its domain? Its domain looks like it never crosses the y-axis, so it looks like I'm going from negative infinity, and I can get close to what? Close to the y-axis, which is the x equal to 0, but I don't cross it and continue from 0 to what? Positive infinity. And then the range, it looks like I never cross the line y equal to 0. It gets closer to it, but it doesn't cross it. So it looks like I'm going from 0 all the way to what? Positive infinity. And you can also look at increasing. So you can see that from left to right, the graph is increasing, and then it kind of somehow jumps and continues from decreasing. All right. So it's increasing from here going, and then it's going to jump off and continue from here. So it's decreasing this way. So it's increasing from negative infinity to 0, and then decreasing from 0 to 0 to infinity. All right, so these are reciprocal functions. If they are even, they behave in that manner. So if you have 1 over x to the 12, you know what is happening over here. You can sketch it. On the y-axis, they're going further away, and then on the x-axis, they're getting closer to it. All right, now let's look at the last one. So the last one here is when I have odd powers. And to do this, you can clearly see that when you sketch this 1 over x, 1 over x cubed, 1 over x to the fifth, you can see that the graph, again, has got a horizontal asymptote and a vertical asymptote. Okay, so this is your vertical asymptote, this is your horizontal asymptote. And so when we sketch, you can see how this looks. This looks like that, and it's also looking like that for each case. So that's how the graph behaves when you have a 1 over x. Again, the higher the odd powers are, the further the graph is away from the horizontal, and the closer it is to the what? To the x-axis. So use that pattern to help you sketch these functions. Okay, so what I try to do is to give you these basic block functions. So we looked at reciprocal functions. They have two types, even and odd. Get comfortable with how the shape looks like. All right. Again, we looked at radical functions or root functions. And again, in even and odd, you should get comfortable to see how the graph looks like. All right. And then we also looked at power functions. And again, over here, you should recognize what's going on when you have an even part and odd power so that you are able to kind of sketch these functions easily and readily when you encounter them. So on your notes, I want you to keep track. Just know what these graphs are doing when you have x to the n, when you have the nth root of x, when you have the reciprocal function 1 over x to the n. It's even and odd. Put it somewhere in your notes so that you can always go to that when you have that function. And then from the previous lesson, we looked at absolute value and then the greatest integer function. Have those make up your complete list of basic block functions so that you can refer to them anytime you need to use them for work. Okay? All right. Thank you.